Data in machine learning is very crucial, and in this video we will see how this data can be used in different ways. Remember that there are multiple ways and multiple methods of accessing, interpreting and representing the data. We'll be seeing only one method in this video, as this is an introductory course. We will be exploring limited features which are related and which are required in the machine learning algorithms. You can explore it based on the availability of time and resources. So in last video we saw the NumPy library, and in this video we are introducing another library, that is pandas, and it is another famous and popular library. It is used by the data scientists all over the world. We are importing pandas as PD. So this is our first cell where we are importing two libraries, NumPy and pandas, and in the next cell we will be loading one CSV file. Now again, as I said that there are multiple ways of loading CSV files and interpreting CSV file. There are other options also, like you can have JSON file, or you can have some database file, or you want to access some files from the resources. So we will see them in different ways in different examples in coming lectures. In this video we are focusing on the CSV file, a comma separated file. This housing.csv file basically contains different attributes of the data related to the housing price. So this file basically has multiple fields, and we will be extracting those fields, we will be saving those fields, then we will see how these fields can be used in our machine learning algorithms. So the first line of the cell refers to read CSV function of pandas. It will read the data from the CSV file. The default parameter for delimiter is comma in the read CSV function. So if you are passing a comma separated value files, then it will understand that this is basically a comma separated file. So all the fields in the file are separated through comma, but it's only applicable for the CSV files with the default parameter. So if you are not providing any specific mention about the delimiter, then by default it will take this as comma. So once I run this cell, it will automatically read the CSV file on the given location, and then it will store the data in a variable called dataset, and this is a data frame basically of pandas. Again, if you want, in case if you have a CSV file, mostly CSV file refers to comma separated value files, but in many cases the people use different ways of separating the values. So in case if you have a file where you have the separator, the delimiter is not comma but it's a semicolon, then you can use delimiter variable, and then it can give you the data by separating the values with the help of delimiter specified here. There will be another instances also where you have the column headings in the data which are there in the CSV files, and you want to skip some of the rows. So in such cases you can use a skip rows parameter while calling read CSV, and this skip rows will skip the rows number of rows. So in my CSV the column headings are there, and I want to skip the first row of column headings. I can say skip rows equal to 1, and then it will skip the first row. So in either of the case, it will read the data from the CSV file, and it will store the data in a data frame called a data set. So if I run this, the data is now stored in the data frame. Once the data is stored, I can see the data, and I can use the head function where I can see the initial rows of the data. So if I run this, I can see the initial 5 rows of the data by default. This data contains column headings like age, total rooms, total bedrooms, population, and median house value. So if you see the data is shown in a tabular format, and it shows only 5 records. But if I want to specify how many initial records I want to see, then I can use the value inside the head function. So if I say I want to see the first 10 rows, it will show me the 10 rows from the data set, and I can refer to that for my understanding. It's about seeing the initial data or the first rows. Now if you want to see the last rows, then you can use the tail function. So if I run the tail function, again it will show me the last 5 rows of the data set. But if I want to see specific number of rows from the bottom, I can specify that value in tail. Suppose I am saying that I want to see last 10 rows, then it will show me the last 10 rows. By writing the dataset command, it will show you initial 5 records and the last 5 records. So you can see first 5 rows and last 5 rows. The data in between is truncated, so you cannot see it. But you can see the total number of records in the dataset. There are 20,640 rows and 5 columns. If you see the data, there are total 5 columns: age, total rooms, total bedrooms, population, and median house value. So in case if I want to segregate this data, if I want to separate the number of columns in different frames or different variables, then I can use the technique called dataset.iloc. Again, there are multiple ways of doing this. This is one of the methods. So if I say that the columns age, total rooms, total bedrooms, and population, these 4 columns I want to save them as X. So I say that dataset.iloc, and then I am using a method by which I can split the data. When I say colon -1, it means that I want all the records. First column says that I want all the records, means all the rows. The second argument says that I want all the columns except the last column. When I say -1, I am saying that I want all the columns except the last column. So it basically says that you want all the records, all the rows of all the columns except the last column. And then if I print X, I will be able to see all the columns except the last column, because I have excluded that column from my dataset X. I want to divide my dataset into 2 parts, X and Y, so I have divided it into X. Now I'm creating the other part of the dataset where I want to use only last column, that is my median house value. So in that case, I'm calling that as Y, and I call the same function again, dataset.iloc. Again, I'm saying that I want all the rows in the first argument, and then I'm saying that I want only the last row. When I use -1 first, it means that I want only the last column. I don't want any other column except -1. So if you see the difference between X and Y, in Y you are putting -1 first, and in X your -1 is last. So in X your -1 is after the colon, and in Y your -1 is before the colon. And then you can print Y. So once you print Y, you will have only 1 column. So your data, which had 5 columns, is now splitted into 2 different variables. So one is called X, having 4 columns and 20,640 rows, and the Y, which has now 1 column and same number of rows. This is a type of data frame, so I just wanted to show you that what type of variable Y is, and it can be seen by running the command type Y. So you have all the data divided into 2 parts. So the first part referring to 4 columns, first 4 columns of the data and all the rows, and the second part as the last column. Suppose if I want to have only 1 column from the X, my X has 4 columns and I want to print only 1 column of X, then I can specify the title, I can specify the column heading inside X, and then I can print it. So if I run this X and age, it will show me all the records starting from 0. The first record is 41, then there is 21, 52, 52. So you can see all the records are there. You would say that why the age is not printed, the column heading is not printed, because it is not required. It's only 1 column which you are printing, so there is no need to print the column there. At the bottom you can see the name of the column, length, number of records, number of rows are 20,640, and the data type is integer 64. Now let us try to convert this data frames which we have created, which belong to pandas, into the NumPy array. So I want to create my Y data frame into the NumPy array. So I can do it by using np.array function, where I have to pass the data frame and I can store it into the new variable. So if I run this, it will convert my Y into the NumPy array, and the shape of the Y is again 20,640 by 1. Similarly, if I want to convert X into NumPy format, and X is a matrix because it has multiple columns and multiple rows, so I'm using np.matrix and I'm passing X there, and then I'm printing the X underscore np and its shape. So I can see it now. It is having the rows, 20,640 rows with 4 columns, and each row has 4 values. I have kept some cells for your exercise. I hope this will be useful. So in this video we have seen only basic data handling operations, and this will be somewhere useful in the upcoming algorithms of machine learning. I wish that you will explore it in detail to know more about this data handling, and then we will be able to use it very comfortably in the upcoming videos.